This is for you, Izzy and Gavin. We're recording the lesson. Hope you feel better. All right. So we're going to do 20.2 and 20.3 today. And we've been dealing with quadratic equations, and in particular with their graphs, right? So a lot we've been dealing with quadratic equations as graphs. What is the graph of a quadratic equation? What's the word for it? Parabola. Fantastic. Somebody other than AJ, what shape does a parabola have? Tell me some characteristics of a parabola.
It's like a U.
Okay. How is it similar?
Rounded.
How is it similar, Annie? Expound upon your answer. It's like a U. How is it similar to the letter U? How is it different from the letter U?
The vertex isn't. It's rounded when it comes to the vertex.
Okay, it's rounded when it comes to the vertex. That's one way that it's similar to a U, correct? Right?
Yeah.
And then what's one way that's different from a U, from the letter U? What about the sides?
Going forever and
Yeah, and the letter U, they go vertical, right? And in a parabola, do the sides go vertical, Christian?
No.
No. What do?
They just
They go out and out and out, right?
Yeah.
Cool. Awesome. So that is, but today, now in 20.1, we started talking about how we can find the solutions to an equation by graphing a parabola. What part of the parabola were we using to find the solutions of an equation?
Vertex.
Close but no cigar. There are two other points. Typically it's two. Could be 0, 2, or 1. That are on the parabola that tell us the solutions to an equation. They are the blank intercepts.
The y-intercept. I mean the x.
The x-intercepts tell us when what is 0.
X. I mean y.
Y. So the x-intercepts tell us when y is 0. So if we take a quadratic equation and we put all the x stuff on one side, make the other side 0, then we graph this, right? Graph all the y values that this side outputs. Then anywhere that that's 0 will be a solution to the equation because it makes the equation true. So we've been graphing parabolas, finding their x-intercepts and saying, okay, these two x values could be solutions to that equation because I got everything to one side and set y equal to 0. Right? Everybody following with me?
Yeah.
That's catching us up on what we've covered so far. So now we're going to continue to look at how we solve a quadratic equation. And remember, so something such as, like if we had, like 0 equals x squared plus 5x minus 12, right? That's the kind of thing we've been doing. And that's where we would then say, okay, we're going to call this y equals x squared plus 5x minus 12. And we're going to solve this, find the values of x that make this equal 0 by graphing this, right? So we're solving by graphing. So we're solving this by graphing this and finding where it equals 0, right? Everybody follow what I'm saying so far?
Yeah.
So remember that there are 3 ways to represent a function. As a table, as an equation, and as a graph. And we can move between those 3 ways of representing a function or a relation. We can move between those 3 in order to find out things about it that we can learn in different forms, right? You like my move there?
I do.
Yeah. All right. I saw the smirk come across your face.
Yeah.
All right. So today we're going to talk more about solving an equation like this when our quadratic equation is in a different form. Okay? So remember, we have standard form and vertex form. We're going to introduce one more form that's very helpful for solving quadratic equations without graphing them. Everybody with me?
Yeah.
So we can solve it, leave it in equation form. Leave it in the expression as an equation, not a table, not a graph, but an equation. We can leave it as an equation and solve it without graphing when it's in this third form that we're about to look at, okay? So the form that we're going to look at is called factored form, also called, I believe, intercept form. Yeah, intercept form or factored form, okay? And this form looks like this. It is y equals k times x minus a times x minus b. Okay. So a particular example of that would be, say, we're like on page 952. Okay, on page 952. If we had y equals 2 times x minus 1 times x minus 4. Okay. So this is, how do I know, somebody tell me, how I know that's a quadratic equation?
Because they're in parentheses.
Okay, what do you mean?
They're like they're in the parentheses, you know. And there's something that can be distributed, 2x, 2.
Okay, but so what is the marker, Annie, ready? What is the marker, what's the thing I'm looking for when I see an equation to see if it's a quadratic equation? X squared. Okay. Now, is there an x squared here?
No, but you can find an x squared
How?
in the parentheses since they're being multiplied x times x equals x squared.
Fantastic. So what Andy said was, right here, there isn't an x squared immediately apparent. But if we were to expand this, we would end up with an x squared being our highest degree polynomial, or highest degree monomial in the polynomial. Okay?
Mm-hmm.
So now I want to show you, okay, and I'm kind of combining lesson 20.2 and 20.3 because they sort of break it up. Could you put this in standard form if you wanted to?
Yes.
Yeah, you could.
What would we do?
We just you multiply the first times first times last, and then last times last,
And the inners.
and then.
So sure, and then you have to multiply by the 2, right?
Oh yeah. That's isn't that after?
Yeah. So the first thing I would do is multiply these two binomials and then multiply by this 2.
Yeah.
Okay. So this is on page 952, and so that would look something like this, and this would become x squared minus 4x minus x is minus 5x. Negative 1 times negative 4 is positive 4. Okay. Then I would multiply everything by 2, and I would get 2x squared minus 10x plus 8. So sure enough, we end up with what, Christian? This is what kind of equation? The kind we've been talking about for the past 2 modules? Starts with a Q.
Quadratic.
This is a quadratic equation. How do I know it's a quadratic equation?
Because it has x squared.
Because it has x squared, and it does not have an x raised to a higher power.
Mm-hmm.
Okay? X squared is the highest power of x that we see. It's present, and it's the highest, so this is a quadratic equation. Now, so sure, we were right. This is a quadratic equation. Okay? And you're going to get practice on your 20.2 homework in doing this. Okay? We've done this plenty by changing vertex form into standard form. Okay? So I'm not going to harp on this too hard. But everybody's with me on how we just did that, right?
Mm-hmm.
Okay. And you may have a little more work from here to here than I do. Okay. Now, but I want to look at it in this form real quick. Okay. So somebody tell me again. What is an x-intercept? When y equals 0. Okay. When y equals 0. So AJ, in this form, factored form, also called intercept form, okay? Factored form or intercept form. Where is y? Not a trick question.
I know, it's right there.
Right here, right?
Yeah.
Okay. So, when will y be 0? Still not a trick question.
when it crosses the x-axis.
Okay? And in terms of that expression, when will y be 0?
When x is 0, maybe?
That's a good thought. Okay, that's a good thought. What operation is being used over here?
Multiplication.
Multiplication. When I am multiplying, how do I get something to equal 0?
Times it by 0.
Right. So, Kristen, did you hear what AJ said?
I did.
What did AJ say?
To be honest, I'm not quite sure.
Oh, okay, so you did. So we said, right? There's how many things are being multiplied over here?
4, 5, 5.
3.
Three.
Okay. I see what you're doing. You're counting each of these, right?
Well, yeah.
Yeah. So these are being added, subtracted. Then this whole thing is being multiplied by 2 other whole things.
But no, because you have to do. It's x minus 1.
Right. We would do x minus 1 first.
Right.
But we're doing that inside. But if I go this times this times this, that's what we're kind of doing, right?
Uh-huh. Yeah.
So Annie, right? Or no, let me stick with Christian.
Yeah,
Stick with Christian.
Yeah.
So AJ told us that if I'm multiplying and I want what comes out to be 0, then one of the things I'm multiplying has to be 0.
Yeah.
Okay. Name me which one could 2 be 0?
No.
No, it's 2.
Correct.
Right? Could x minus 1 be 0?
Yes.
How?
If you just subtract 1.
Yeah.
If x is 1.
If x is 1, then x minus 1 is 0. Did we follow what we just said? Okay, fantastic. And then one more, we're going to double or nothing.
Yep.
Okay? Could x minus 4 be 0?
You can.
How?
If x is 4.
If x is 4.
Uh-huh.
Right? So, anybody can raise your hand or holler it out or whatever, or like jump up and get really excited because this is amazing. Right?
Yes.
Name me what values of x will make this whole side 0.
I got it.
Okay?
Now, what do you mean by values of x?
What can I plug in for x that will make
0.
this side 0?
No, because that's -4 and -1.
No, 1 and
It's okay, AJ. I got it.
1 and
It's
4.
fine.
1 and 4. X could be, so listen, when x equals 1, y equals 0, and when x equals 4, y equals 0. This is 4. Okay?
The way you
Y
said it
equals
made
0.
it seem like x had to be the same number.
Yeah, that's right. So what values
Yeah.
of x would make the right side 0? So here's what we found. Okay, we now know. We know what values of x give us a y value of 0. Okay, so we are now in a position where we know that like if we set this up like this one, okay. And we have something in factored form set equal to 0, we can solve it just by looking at what values of x make each of these factors 0, right? Because remember, that's what we've been doing in 20.1. We've been saying, let's find when the x side, the right side, equals 0, and let's do it by graphing and finding the x-intercepts, right? That's what we've been doing. Now we're saying, if our quadratic equation is in factored form, I don't have to solve it, okay? I don't have to graph it. Sorry, I don't have to graph it to solve it. I don't have to graph it. I can just look at what values of x make each of these binomials 0, because when either of these binomials is 0, please keep your head up. Please sit up, okay? If either of these factors is 0, the whole thing is 0. And that's what we're looking for when we do the 20.1 graph to find the x-intercepts thing. Right?
Right.
Okay. So this form makes solving very easy when the left side is equal to 0. Okay?
But doesn't finding that make putting it in standard form unnecessary?
Well, so sometimes, so far, we don't have the tools to factor. Okay, so there is a way to get from here, especially if this were 14. Okay, there is a way to get from this form to this form. You have not learned it yet. Okay, it's called factoring, and so we can find the factors of this trinomial and write it as a factor, a product of two binomials. So this makes converting to standard form not necessarily as important if I know this, okay? But if I'm presented with this, I still need to know how to graph it. So that's what we've been doing. Okay. Cool. And we go from here to kind of reinforce in our mind that this is in fact a quadratic equation. Okay. So let's practice a couple of things that we've covered so far. Okay.
Sounds good.
Let's do. Meet me on page 952. Okay. Page 952. Can I erase this?
Yes, you can.
All right. For now, I'm going to call this intercept form. Okay. No, I'm going to call it factored form. I like that better.
Mm-hmm.
Sounds cooler.
Yes, and it's more accurate. All right, so let's do 5 and 6 on page 952. Okay, try 5 and 6. Try expanding those into standard form. Okay. We'll be right back with the second half of the lesson in another video.